page down there at the bottom, the statistics examples page. As Robin said, we teach about unions and intersections and those sorts of things in probability a lot less than we used to, but this is one from Peter Stark at Berkeley. A very nice one. We have two sets A and B, and you can change the overlap by dragging B. And if you click over here, you can change which part of the thing you're looking at. So there's A, there's B, there's A or B, A and not B. And you can see the proportions, the probabilities are changing down there as you move this. The overlapping of the sets, the probabilities are changing, the intersections and unions down at the bottom. Very dramatic way. If you're still teaching Venn diagrams, this is a great tool. There are a lot of others. There's the visit to my book, which we can do again in the second session this afternoon. There are a couple of Java-based packages that deliver statistics programs. WebStat, which may not continue to be publicly available, will be part of CyberStat, and Statlets. Boy, I wished I'd grabbed that name early. It's a great name for Java applets to do statistics. That one has is free for academic use, and it's got all the standard statistical tests and nice graphs and so on. It takes a while to load, so I'm not going to visit it here, but if you need a stat package, and your university will give you the computers, but they won't give you the stat package, these two are free ones that you can use right now. Go to the next page, Science. And click on orbits. And again, you have access to this website. You can come visit these and play with them. This is Physics 2000. It's one of those things I had to go to a conference before. The guy who was working on this, David Ray and Marty Goldman, in the physics department across the street. I could throw a baseball from my office to their office, and we finally met up at a conference and realized we'd been doing applets. With some of the same goals in mind. These are amazing in my view, and they're not mine, so I get to use those kinds of words. Here we have a central gravitational source. You can think of these as planets around the sun or electrons around the nucleus. But take your mouse and you get a little planet or whatever and draw a line. That's going to give it energy. The longer the line, the more energy. And then it'll go in that direction. Oh, and that headed out. Whoops, that's a comet headed out into outer space. There goes one. Notice how it speeds up as you come around, and there's a lot to be learned by orbits. And that one we sent off, we sat here long enough, it will come back. But Haley's comet. The program has not forgotten that. And we could start one maybe in the other direction.
Three-dimensional.
Asteroid.
And then you can put the force fields in so you can see what happens to them as they go around. And all of the equations underlining orbital mechanics come alive doing this sort of thing. Illusion works.
Where do you find it?
I'm sorry, I'm back to the science page on the examples.
Okay, thank you.
You click over here.
Okay, thank you.
What was the name of it now again?
This is the ball and cast shadow illusion. this one, you can just see it up here. Here's this ball going back and forth. What do you see? What does it look like is happening? Does it look right?
Well, it's rolling on the surface.
It's rolling on the surface. Some people see it as a little jerky. It's not quite right. There's something disconcerting about this. It might help if it had a shadow. So we'll put a horizontal shadow on it. I thought you said it was going along the surface. You see quite clearly that it's low and going up. It's rising above the surface. Well, that's if it has a horizontal shadow. What if it has a diagonal shadow? Now it's rolling across there. If you get rid of the shadow, it's doing exactly the same thing all the time. It's completely an illusion. And let's put both shadows on. And we were wrong all along. It's bouncing across there. Again, you can't do this on paper. You can't talk about this illusion on a perception class. That's the point, to try to open your eyes to the kinds of things we can do. I'll skip over those for now. The sorting algorithms. I don't know if the colored light one works.
What'd you do next?
I'm down at the color light ones, the one from Brown down at the bottom of the science page.
Okay, go back to science then.
Uh-huh. Again, maybe it's taking a while to load that. Maybe just watch up here. Again, you can play with this. We're also dependent on their server. These days, the networks are so good that the speed of what you get is mostly a function of the speed of the computers at either end of the pipes, not the pipes themselves. And here you can create lights with different energy at different frequencies. And this is how it would look to the amount of energy going to the red cone system, the green cone system, and the blue cone system in your eyes. And this would be the apparent color. And now the task is make one over here that has the same color, not white on, but you can see how you can play with that. When you take some away or add it, and learn a lot about color and interacting with it in these ways. Go to the databases, click over here on the left on databases, and go back to the Challenger example. I think every discipline has had its shot at saying the Challenger shuttle disaster would not have happened if only they listened to my discipline. And statistics has done that. Those of you who've read Tufte's books probably have seen this one. Well, it's somewhere getting out of here. They were trying to figure out, before they launched the Challenger, the temperature of about 32 degrees, whether there was any relationship between temperature and O-ring failure, rings that hold the sections of the shuttle together. And so this is how they actually did it. They got in their database and they made a fundamental error. You wonder, surely some of these smart folks have been taking the statistics course sometime. But they made the fundamental error. They decided that cases where there hadn't been any problems weren't relevant. So they eliminated all of those. Those just happened to be all the warm ones. And that might have given them a clue that there was some relationship between temperature. Although there was one warm day where there was an accident, an O-ring problem, not an accident, O-ring problem. So that one warm day was compared to one cold day, And the amount of O-ring failure didn't differ between those 2 days, so he said there was no relationship. And they actually convinced each other about that by faxing transparencies like this back and forth to each other. This is what they were doing the day before the shuttle launched. Those are the actual transparencies. And here is a graph of the data. Here is temperature along here. Here is the degree of O-ring failure. First of all, down here is the temperature they were going to launch at. That they did launch at and lost what? 32 degrees. Down in here. They knew the temperature was going to be below 40, somewhere in here. The day before. And they wanted to know if it'd be okay to launch. Here is the graph. All of these points where there was no failure, they threw out of the data set. They only looked at the remaining ones, and they looked particularly at this one. And notice the interactivity in this graph. You can see the details. That's the temperature and the amount of O-ring failure. You can even do things like they had little images. Here is the actual shuttle that was launched and where the failure was, and I'm sorry, my scan of this came out to be too small, but you could get the idea. I threw this together. I threw that graph, interactive graph together, and probably less time it took them to make out one of those hand transparencies they were faxing back and forth. Once it was available, that graph was available, anyone in the world could have looked at it, gotten the detailed information. This is the way we ought to be accessing information from databases, not by tables and text like they were doing. But they failed to detect this kind of relationship here, launched the shuttle at this temperature and lost it.
Gary, can I speak to that just a little bit? At the time of the shuttle disaster, I was working, one of our divisions was an aerospace company. And they published, NASA published maybe almost an inch thick with lots of color pictures. And I was in the quality department and we reviewed the book because we have a number of instruments on this shuttle. And to me, the telling picture in the book was the plume of light. Plume of, I don't know what it was escaping, this is 15 years ago. But something was escaping from the rocket, pointed right at the hydrogen tank. Now, if that had been in any other quadrant and maybe only 20 degrees difference, then the rocket gas may not have melted the hydrogen and floated the hydrogen tank. So even though it was cold, it could have gone off, the O-ring could have failed, and the whole thing could have been in. But it was pointed right at the,
No, those other ones were significant O-ring damage, but
yeah.
right. So its correlation wasn't one. Interesting. Here's another example. My university has put together a nice schedule planner, and one of the things you can do is get the faculty course ratings. And it returns them as numbers. So here are all the instructors. Well, in fact, some of these are the graduate students teaching labs. There's no distinction made between professors and TAs. There's no distinction made between who's teaching the course now and who taught it 10 years ago. You can't take it. You couldn't enroll from the course from most of these people. And plus, you got this list of numbers. Who wants a list of numbers? With the web, with delivering images, we can be much more creative than that. And you see the throwback. Anyone recognize this? Old enough to recognize this? That's how they used to stripe computer paper. The big paper that came out had stripes like that. So you can throwback to an old thing. This is virtual computer paper right here. Bad idea. And let's hope this one works. So what if instead the same information had been returned in a graph? And These, in fact, honor student did this as a project. We had a number of different graphical representations, and so we used fictitious names but real data. We didn't want any of the colleagues, any people who might have been on her honors thesis examining committee, know they were in this database with their course ratings exposed here. But here is a percentile graph of all the course ratings of professors teaching the introductory stats course here. And you can find out each one. And Young, spring 96. Young, fall 93. You know, someone besides Young. Young. Boy, I know I don't want to take a course from Young. And how long would it take someone to extract that information from that table I showed you and all that list to get it easy? And you can see the large variability on an A to F kind of scale that the students are rating the professors. Some very good instructors up here, some very lousy ones down here. The department chair might want to see a graph like that. Could not extract all that information from that table. But that's not the student's task. The student's got to take the course this term. Who to take it from? Well, 10 o'clock. I can probably get up at 10 o'clock. Well, there's where that instructor is in the distribution. Well, that one, 12:30, let me sleep later, but that's not a good instructor. 9:30, could that be worth it? Oh, thank goodness. I'll go with the 10 o'clock one. And then we had a thing down here where they chose which one they wanted to enroll for.
This seems to me to reflect the quality of the data. You have to question the data. If I were a student, I would question the data. Who knows what those numbers are?
Well, they generate, their peers generate the data.
Right. I mean, you trust your peers.
I mean, there's a lot of debate about using student course ratings, but if we're going to, the university went to the trouble of collecting them,
Sure.
putting them in a database, returning them to the students as a table. If they're important, why not return them as a graph? Some students may want to use it, some may not. Some may want to make the choice based on time, building, and so on. Or you may want to look here and think, gee, Weatherby keeps showing up there. Maybe I'll wait till next semester to see if Weatherby's teaching. But a very different way of interacting with information if we can change it from tabular representations, these things, these databases on the web spit out at you all the time, to this kind of representation. And the point is, that one was built with commercially available class files, Java class files. I'll show you in a bit how to put that together. Any one of you could put a graph together like that and use it in your class if you want. You were asking about building your own applets. I don't recommend that too many people get into writing your own Java code, but there are a lot of construction kits for graphics in Java, and you can put those pieces together. With actually no Java coding, just HTML stuff that you can put together a website. Here's one I like, a very different area, mortgages. And this is the representation of the principal payments, the red, and the interest payments and the principal payments. Part of your mortgage payment each month that goes to those different parts. You can see how that would be affected. 7.4 isn't the interest rate anymore, it's up to 8, so we can move the interest rate up and things change. But then it's 9%. You can go down here and what if we put in an extra $100 each month? How does that change things? Well, there's our $100, and you can see where it changes the cross point between principal and interest. Very different representation of information we've all seen in amortization equations that students get, or anyone gets, a lot better than gone to the principals page, and Tufte is always a good place to start. There are links there. Some of these are broken. Just checked these the other day and I haven't had time to fix those. I'll try this one again. Not everyone try this great use of interactivity, but you may want to try it at home. How many of you know about Tufty? Oh, you all ought to go home and read Tufty. Follow these links, get the books from Amazon.com. Tufty has wonderful books on graphical representations. There's one, the display of quantitative information, which he calls the numbers book, and then, I forgot what the other names are there. One he calls the nouns book, and then the verbs book. 3 different books on graphical representations. They're beautiful. He couldn't get publishers to do them to his standards. The first one, so he mortgaged his house and published them himself and had detailed control. They're beautiful books, but they're not expensive. You got to have them. They're wonderful. And it says 91%. Okay, this is a Noah one. And again, I don't know why Java has become a hotbed in Boulder. I guess I do know there's so many techie folks in Boulder and institutes and so on. This also was written by someone who would have taken a short bike ride for me to get to his office. This is hundreds, thousands of precipitation reporting stations in the U.S. So let's load some data.
Excuse me, how'd you get to the way you are now?
Under data, this is under principles.
Yeah. Present something.
No, not Tuffy. Down at the bottom. That one.
Great use of interactivity.
Takes a while to load that, and then it looks like we're getting a slow feed from the database. Oh, come on, I wanted to show this one to you.
Those top 3 did you use next to meteorological or?
It's loading an applet down here.
Oh, I see.
Would you use a spatial statistics effort to understand what this is? Any idea?
Oh, I see. 6.
Obviously, there's data someplace, but you have to use some type of a mapping program.
Okay, I did not write this one. It's got this basic map, and these are all actual locations. Contacting host, waiting for a reply. We're having troubles on the net.
Should we not ourselves nominate to free you up?
What?
Should we not load it ourselves to free you up?
Probably. I don't know if that's what the problem is, the waiting for the reply. Maybe it's... Now it says transferring data. So I guess so. Maybe stop here for loading. Let's go back, click on principles. Here we go. So here's the detail. This is where it was raining a lot. See where we are up here. Anyone recognize any of these local names? Watertown.
Down to the left. Below the lake to the left.
Out of the lake.
That's close.
This is getting small.
Victor, wow.
Victor.
There you
There you
go.
go.
There it is, near Atlanta.
Huh?
You're at one.
So incredible amount of information available, and if you wanted the, let's see, there's some place, the station reported daily data. Many of these have hourly data.
They have pressure, their pressure as well as temperature.
No, this one just has precipitation. And this is looking at precipitation and there are all the rivers, and it's for looking for flooding and so on. But incredible amount of information. If you looked at this in the table, you couldn't possibly process it. But here in this visual representation, you look around, find access a lot of different ways, and there's a lot to do with this one. I urge you to come back and play with it. It's extremely sophisticated and interesting.
Your picture there reminded me of the isobars and weather maps that I think are wonderful.
Right. I use having mountains right next door, and then even maps on the web with contour intervals to talk about and do the same sorts of things. So there's starting to be research about how people process information in graphs. And this is an eye movement analysis. We shine a little beam of light off someone's eye, so it doesn't, small enough it doesn't bother them, but you can tell where their eye is looking. And underneath here is a graph on age in years and vocabulary score as a function of TV hours watched. Okay, so how does someone get information out of this? Well, what you see is the width of these lines is where is density and number of times they went. So there are a lot of eye movements from the center of the graph down to the axis. You've got to figure out where you are and so on. Or out to this axis, and that's where most of the eye movements are. Well, maybe we ought to be making our graphs differently, particularly on the web where we have interactivity. What do you want to do with interactivity? Some of those bad examples that don't work, where some of these commercial people, these programmers, know nothing about statistics or graphical representation of data, but they knew they could figure out where the mouse was and do cute things with it. So they allow things to have tilted pie charts that you can spin. That does not help the communication of information one bit. It does, however, allow you to show that why you should never use a tilted, I don't like pie charts anyway, but why you certainly shouldn't use a tilted one, is because you can rotate it and you can make one of the wedges be apparently larger or smaller. It's a perceptual illusion depending on where you put it. And so it's really a device for applying the statistics. You can just try it out. And there are ones where there are 3D bars where you can change the degree of tilt of the bar. Don't use interactivity for that. We could use interactivity. Why not just let the person move the axis up to where it needs to be? The axis can follow the cursor around. So if you want to know what's going on there, that's not implemented here, but from studies like this, I think we'll figure out what we need to be doing. Again, I'm now at the point of just giving you a guide to this site. In the second session after the break, I can help you visit any of these, but these are a number of commercial sites where you can buy Java applets for presenting graphical information. Some of them are pretty conventional, some of them are very powerful. This is the one, NetCharts was the one I used to do the Challenger one and the course rating one and so on. If I were going to deal with anyone, the NetCharts folks are very good. And, I've gotten evaluation copies of all of these at one time or another, and I generally write back after I've seen some of the garish things they've done. I say, have you ever read Tufte? And I get one of two responses. One is, Tufte who? And the second one is, yes, we read Tufte. Yes, you're right. That's a dreadful graph, but that's what those business people want to buy. You know, we're in the business of making money, so we sell them the various three-dimensional bar charts which misrepresent information and also contradict.
I stumbled on one of his books because I order library books for our math department, and your library would probably be more than glad if you asked them to buy all three of them and buy them in a separate. That's what we had. That's what I had to do. I said, math part one season. It's mine.
Well, they're so wonderful. They're coffee table books. I mean, they're beautiful.
If you don't want to buy all three yourself, you want to go buy computer software.
You can buy all three of them for what you can buy most software programs for. So you don't have to do it yourself. The actual how-to is back here. There's some sources for a lot of applets, and Robin's going to have, he had some sources for his. There is the code for the Challenger one. And it's just HTML stuff. You don't need to know anything about Java. Here's the applet tag that you use. I don't know how many of you have ever done any web page coding, but this is all you need to do is stick in applet. Code base tells it where to find it, and that was my copy of NetCharts. Which of the NetCharts you wanted to use. I wanted to use their XY chart, and I wanted it to be 600 by 400. And then I just specify all these things. I wanted a white background, here's my header, wanted Helvetica, 14, so on. They built all of that. And then down here are the data set. And the active labels, that was what allowed it to click and open a new window. And the active clicks, or the dwell, I'm sorry, the dwell is what allowed it when I put the cursor over a data point for the values of the point to pop up. And it's not hard. Any of you can do that. And you can put together a lot of interesting data displays doing it. There's the course reading example. You can look at those and see how to put them together. On the frontiers, well, that one's probably going to, these two both may take a while. We'll see if they go. This is really avant-garde stuff. And again, when my book's seeing statistics, I'm using the book metaphor. Well, there's a page 1, a page 2, and a page 3. There's a table of contents. There's something that looks kind of like an index. There's a glossary and references and so on. But are those the kinds of metaphors we should be using in a new way of doing things? You've all probably seen a thesaurus. Here's a thesaurus. Interesting three-dimensional representation of one. Experience is at the center of where we are. And these are all words related. And there's some way to slow this down, given this. I don't know if I can do that, but I clicked then on live through. And that refocused where we were. So you're going through this nexus of words, a real net. There's one put together by the same people. I urge you to visit it. On the same page, the Museum Without Walls. Again, when we started putting things on the web, there were virtual museums. And they implemented museums. There was an entrance hall. You went in the entrance hall. And you could go left to go to Impressionists, and forward to go to Old Masters, and to the right to go to Modern Art. And you went to that room, and then you could click on different things. There was all this metaphor exactly representing what we do in real space. But there's no reason to buy into those metaphors. And so the Museum Without Walls has this same kind of thing, where you can wander around and go through the walls. That's what's nice about a museum. I mean, the bad thing about being a physical museum, I'm here at the Impressionist, but now I go see the Little Master, and it's a long walk. It doesn't have to be a long walk if the things are connected in very different ways. And so there are some very avant-garde things. And we're getting really past time we should be breaking. So I will stop now. The point is, you can get access to this website. You can go play with these applets, and if you're the only one visiting them, instead of all of us trying to hit them at the same time, that'll be quicker. And hope you explore a lot of new graphical ways for representing things and not do virtual things.
That chart you said is a commercial product.
Yes.
How much does it cost?
You can negotiate with them, you know, for academic institutions versus, I don't know, but it's $300 maybe.
Using the word applet, I'm not sure.
Oh, applets, the Java programming language, you can write little programs. And so instead of calling them application programs, they call them applets, A-P-P-L-E-T-S. And they can be embedded in web pages. And so all of these things you've been seeing have been interactive with them applets. They are an application that comes with the web page, but it's downloaded here. And this is not being run by a server somewhere else. This is running on this computer. So once it's downloaded, you don't have to worry about anyone else trying to use it at the same time. That's your copy of it. So it's very fast. That's what once it gets here, the interactivity is very fast. Thank you. If some of you didn't get them, here's this page. This is an exact copy of what's in that McCelland.html file on the disk that Bob put together. And it has all of the web addresses to get you to the basic pages to get going.
Thank you.
So now what, we have refreshments? Or?
Yeah,
There's a break for refreshments, yep.
There's break for refreshments, and then I'm going to be in here
Yeah.
just as coach to
The next hour is going to one of the other rooms, working on the computers or talking to the presenters. Thank you.
Thank you.
You're not restricted, and this Jan was just saying, you're not restricted to come back to here. Go to any of them, go to the breakout session 5, whatever. It's strictly an open.
There's one open lab, right? Lori's.
Yeah, Lori's session 5, the breakout 5. I think the slide doesn't.
A long time to search up. These are all those things.